Saxon Algebra 1. We're going to talk today about denominators in big, creepy-looking problems that need help. And let's dive in. Let me show you a problem. We're going to learn how to help them. Our instructions here are to add. And what we have is a pair of fractions with letters only. Okay? No numbers anywhere in sight. But we can use the rules that we use for denominators with numbers. They have to match, right? We can use those same rules for letters. So we have to make these match. Now, here's a trick. We can only change denominators by multiplying. We cannot add a y to this side. See how this is x plus y and this is x? It would be really nice if we could add y. We cannot change a denominator by adding. We can only change it by multiplying. Only change denoms, by multiplying. Okay? No adding, sorry. I'm a fun wrecker. So what that means when we're finding the least common multiple that we need to make these match, we have to multiply. So in this case, we're gonna take x and we're gonna multiply it by x plus y. I can hear you groaning. I know, that's kind of a pain, but that's just the rule. We can't add to top and bottom, we can only multiply. So if this is our least common multiple, then this one we're gonna need to multiply by x plus y over x plus y. I'm squeezing it in. And this one we're gonna need to multiply by x over x. Does that make sense? We multiply by the piece that's not already there. So now we'll have, I'm not gonna distribute that, we'll have a times the quantity x plus y plus, there's the plus sign, it got buried, b times x all over x times the quantity x plus y. All right, and that is our final answer. We could distribute this a, right? Multiply it by the x plus y, or we could distribute this x. But here's the thing about distribution. It's neither right nor wrong to distribute. So what I like to do at this point is I like to stop and see what John chose for an answer. And if it looks like mine, then we're good. If I realize that John did some distributing, that's fine. I'll go ahead and distribute. I won't look at exactly what he got, and I'll do my distributing. But in this case, the answer looks like this. So we're good. Next problem. Example 52.2. Add 4x plus a Okay, we have the same scenario. This time we have one brave 4 that's showing up to represent, but all the rest are letters. And these denominators, man, these are pretty hopeless, aren't they? But again, that's why I like to call this a least common multiple instead of a least common denominator, because it reminds us that we have to multiply when we're making it. So the only thing we can do is multiply them together. It's x times the quantity a plus b. That's all we can do to make these guys match, is multiply. No adding allowed. So now when we go to fix them, we'll multiply this by what it's missing, which is the x. So I'm gonna multiply this by x over x, Hannah Cranny, top and bottom. And over here, I'm gonna multiply by the quantity a plus b. And I'm gonna keep that quantity in parentheses to make sure that it doesn't get messed up. All right, so now up here, I'm gonna put the x on, this x goes on the outside, this x, and then I'm gonna multiply it by the quantity, 4x plus a, plus c times the quantity a plus b. Okay, I'm not going to distribute those until I figure out if John wants us to. Later on, we will know whether or not to distribute based on what else we have to do with the problem. But right now, the problem isn't going farther than just this, so we'll wait and see what John does. And then our denominator is equal to the least common multiple, x times the quantity a plus b. Okay, now I look at my answer and I can see, oh, John distributed across the top. His answer on the bottom looks like this, but on the top there's no parentheses. Everything is just individual terms. So that tells me, all right, I better do one more step then. So mine matches. I like to go alphabetical when I'm multiplying. John doesn't always do that, but that doesn't matter. X times 4x, 4x squared, plus ax, right, plus ac, plus bc. And all of that goes over x times the quantity a plus b. Right, and that, just double checking. Yes, John arranged the letters in each term a little differently, but he's got 4 terms and it has the same combination of things in it. It looks the same. Yay. 52.3. Here comes another one. All right, this one's weird because we have 3 terms, and the last one is floaty. It doesn't have a denominator. All right, well, we don't have to let that worry us. I'm gonna put parentheses around this because whenever I see a binomial, I just wanna make sure it stays in a neat little bundle. Least common multiple, which we will get from multiplying things together. We can put this over a 1. That doesn't really cause any drama for our LCM. Our least common multiple will be m times x. All right, that's not so bad. So we have to multiply each fraction by the part it's missing so that it will end up with this in its denominator. So this one will multiply by m over m, right? We'll get the mx. This one will multiply by x over x. Notice sometimes I write it before, sometimes I write it after. It's just a question of how much space I have. And this last one just has a 1 on the bottom, so it's going to need to be multiplied by mx over mx. We need everything to build that denominator. All right, now I'm ready to condense this. The denominator should all match. We don't have to write that over again. I'm just going to simplify this numerator. So m times the quantity a plus b. I'm not going to distribute until I take a glance at my answer. Plus cx plus dmx, right? I'm multiplying all over mx. And I am ready to look at the answer, and I remind myself that if there are no parentheses, I'm going to distribute before I check. So I take a quick glance at the answer, and I see, oh, he does have parentheses in the answer, so I can leave it just like this. And I'm double checking the other terms. It's m times the quantity a plus b plus cx plus dmx all over mx. Yay. That's right. Okay? So when I'm looking at the answer, I'm just taking a quick glance. Are there parentheses or are there not? And that tells me all I need to know. You guys, it is an art to learn how to use the solutions manual to help you, but not to make you weak, right? If you rely too heavily on the solutions manual, it'll make you dependent on it, and then you will not feel confident doing the problems unless you have the solutions manual right there. So your job is to try to find that sweet spot where you just use the manual every now and then to make sure that you're getting the problem right and you're on the right track, but you don't rely on it too heavily. All right, let's try another one. This one's gonna get a wee bit harder. Is it? Maybe a tiny bit, not a lot. It's got 3 parts again. Okay, this one's a floater, so let's give it a 1. Okay, first step is always to find the least common multiple. The name reminds us we can only get it by multiplying. We can't add things. So we can see it's going to have to be K times the quantity B plus C. I like to write the single term and then the binomial. It's neater for me that way. Okay. Now we multiply each individual fraction by the piece it needs so that its denominator will match to this. So this one better be K over K. And I'm going to put parentheses around that so it's clean. This one we have to do the whole thing, right? So it's K times the quantity B plus C over K times the quantity B plus C. And then this one's already got the K, so it just needs the B plus C, B plus C. I'm going to put parentheses around that so it looks nice and neat. All right, now let's simplify this, and this is a little crazy. So here we just have AK minus, now this already has a term on the outside and we're multiplying it again, so these guys can just hang out together. So I'm going to write KX times the quantity B plus C. See how I did that? I didn't mess with what was inside the parentheses. I just let X be buddies with K. They'll both be outside dudes. And then if we decide we want to distribute, we'll do that. And then here, we're going to leave this as two binomials. We're not going to mess with any of that. We would have to do the dance, wouldn't we? Because that's binomial times binomial. But we're just smushing these as simply as we can. Everything now has a denominator of K times the quantity B plus C. So that looks good. And now we'll check and just see if we need parentheses or if John multiplied those through. And I see lots of parentheses, so that's good. I'll read it to you. KA, okay, we reverse that, but that's fine, minus XK, opposite order, times the quantity B plus C, plus quantity D plus M times quantity B plus C, all over K times quantity B plus C. Yay! So as you can see, these problems can get quite complicated and kind of messy. So take a deep breath, organize your mind, run around the block if your head feels fuzzy. Staying focused will help you get the right answer. All right, the last problem relates to a topic we call overall average. Okay, it's kind of tricky. They're not hard, but they require you to twist your brain a little. The average of the first 90 numbers was 4. Okay, so what we did was we took a bunch of numbers. There were 90 of them. We added them up. We divided them by 90 because that's how many items there were. And we got an average number of 4. All right. Then we took 4 more, no, how many numbers? Then we took the average of the next 10 numbers. So then we took some more numbers and we added them up and we averaged them. So we would have divided by 10. And the average of these numbers was 6. What is the overall average? Okay, here's the trick. It's not 5. You don't just average these. Because this average represents 90 items, this one only 10. So we had a lot more that were smaller than we did these bigger ones. So what we have to do is work backwards. That's why I set it up like this. We're going to work backwards, and if we divided some number by 90 and got 4, then we should multiply. And we know that these 90 items added up to 360. Now we can do the same thing down here. We had 10 items, we added them up, we divided by 10, we got 6. If we work backwards, we know that they had to add up to 60. Okay? So now what we're going to do is we're going to take 360 plus 60, that's 420, right? I got it by comparing those two. And we're going to divide it by the total number of numbers. So total value divided by total number of numbers, right? equals, and I can do this in my head, dividing by 100 means move the decimal. So the overall average of all these 100 numbers, who we don't know, is 4.2. Okay? So what we have to do, this is the way I want you to do these problems. John does it a different way, but it's confusing. I want you to lay out this little diagram for each of the averages, and then you can draw these boxes, and that is what you use to calculate the overall average, right? 420 divided by 100, okay? Make sure you take this down in your notes. Make sure you look back to this if you have problems. Make sure you watch this part of the video again if you don't get it. Every student scratches their head over this and goes, what? I don't really remember this. It didn't make sense. That's why I want you to draw out the problem like this and then work backwards. All right? 52 is in the bag. Your first week of algebra after Christmas break into 2021 is completed. Congratulations. Thank you. Goodbye.